Hey guys, welcome back to our HIA series. This video today is about the configuration of static routes. But before we can jump into the configuration, let's just check the theory behind a static route. I already mentioned that we are going to cover the basic knowledge of static route. So the aim of this tutorial is for us to understand router's composition and how it is generated. We are also going to clarify on routes and routing table. We are also going to get hands-on whereby we are going to configure our static route on our NSP, which is our simulator, and also verifying those configuration. So learning about routing protocols is very essential for you to understand networking. We all know that routers are primary form of network layer devices used to define a gateway. Routers function as a means of routing packets from one local area network to the next. Sometimes you find that we have to know how does the router make the decision, because you know that routers are responsible for the decision making process that determine the path via which the packet is forwarded. That's how routers make a decision. Or router is responsible for making the decision on forwarding packets. So let us look more on routes and routing table. So the route, the network layer path from one network device to the destination. Let me repeat that again. A route is a network layer path from one network device to a destination. Therefore, we are having a routing table. A routing table stores the information about the routers. It stores the information about the routers. Normally, you'll find that the routing table may be stored on a routers, a computer, or on a layer 3 switches. They function more like a database. So the IP routing table lists all the networks that are reachable via routers. Also bear in mind that the packets that have no routes are subsequently discarded by the router, meaning the router of the packets with unknown destination. So these are the components of the routing table. As you can see here, we have the command here, display IP routing table. This command wherever you want to check your routing table. So we are having the destination, the mask. Here, this is wherever we identify a destination IP address or a destination network segment where that router resides. We have proto, which is the protocol. This field indicates the protocol through which routers are linked. As we know that we have the different kinds of routing protocols, legs of RIP, SPV, and BGP. Those are our routing protocol. So then we have a pre, which is a preference. This one specifies preference value that is associated with the protocol. The preference value that is associated with the protocol. Then we have cost. When we talk about the cost, this is the value that represents metric that is used to distinguish multiple routes of the same destination. This will be metric that will be used where multiple routes have the same destination. Then we have flex or the next hop. The next hop is the value that indicates the IP address of the next network layer device or the gateway, let's say so. The next hop, the value that indicates the IP address of the next network layer device or gateway that IP packet is going to pass through. Therefore, we have our interface. Our interface, this is whereby it indicates the outgoing interface through which IP address is forwarded. So those are the components of the routing table. Therefore, you are going to run the command display IP routing table to check your IP table. So let's just expand. So for routing table forwarding requirements, for router to forward packet, you need to know the interface. Next hop, we have already discussed it. It also need the destination address. We also discuss it, and we also need the IP packet. So let us check the syntax for configuration. This is a very simple concept. We are going to write the word IP route, the IP route. Therefore, then we are going to be followed by destination network ID. The destination network ID. Let me make an example. A destination network ID. Making an example with a class C IP address. So we know that in a class C address, the first 3 octets are the network ID. This is where I am referring to IP version 4. So we know that in class C, the first 3 octets are our network ID. So this is the network ID I'm referring to. Therefore, we are also going to add the word mask. Therefore, we are having the subnet mask, meaning we are having the different option on how we can represent our subnet mask, which is /24, which will be counting the numbers of bits in that subnet. So meaning when you are talking about the class, you know it is /24, is equivalent is 255.255.255. Also, we are going to have the next hop address or exit interface, meaning here we are going to, you can use the next hop IP address, which is the next hop pattern of the router, or the exit interface, which is maybe Ethernet / something. So I think that's much clear. Now let's jump into our lab and demonstrate that. So this is our lab we are going to use for us to configure the static routes. So first step, we are going to assign all the PC IP addresses. So let's begin by giving our PC IP addresses. This is .1, so there will be .6. So let me give my PC IP address here. IP address, okay. I'm going to give them static 192.168.1.6.5.5. Subnet mask class C. Find the gateway, which is .1, the address of the router here, .1, 192.168.1.1. That's fine. And let me apply. Let me assign the second PC IP address 192.168.1.6.6.6. Default subnet mark for class C 255.255.255. Gateway 192.168.1.1. Okay, done. So let's assign this IP address .2 192.168.2.5.5 subnet mask. Okay, gateway 192.168.2.1 okay, 192.168.2.6.6 subnet mask 255.255.255 okay, 192.168.2.1. It's okay. Let's come to our last PCs, the 3, which is the 3 network 192.168.3.5 255.255.255.0. It's okay. 192.168.3.1 3.1 is okay. The last PC 192.168.3.6 255.255.255. It's okay. Gateway 192.168.3.1. So now I've assigned all the PC IP address. So now let's give the routers IP addresses. Ethernet. Okay, let me begin with this router. Let me begin with this router here. Let me begin with this router here. Okay. System view. Router 1. Let's give it the name router 1. Interface Ethernet 0/0/1. IP address 192.168.1.124. Okay, let's come to another interface, which is interface Ethernet 0/0/0. Okay, IP address 10.10.10. Let me check 10.2.2.2.2.24. Okay, now I've given this router 1 IP address. I've assigned this router IP address. So let's come to my second router. This view, this is name router 2. Okay, let's check this interface. Ethernet 0/0 interface big Ethernet 0/0/0 IP address 10.10.10.1. Okay, no, sorry, subnet mask 24. Therefore, let's come to this interface, which is we got Ethernet 0/1 interface. We got Ethernet 0/0/1 IP address 10.10.20.124. Okay, and I've assigned this router IP address. So now let's check this interface, which is here Ethernet 0/2 interface Ethernet 0/0/0/2 IP address 192.168.2.124. Okay, and just run the configuration to check. So display this. You can see that we can see when I want to check the configuration, you can see that this interface has been given this IP address. Okay, you can just quit display current configurations. Then you will see the IP addresses that has been assigned to our router. Okay, now let's come to our last router. This view, this name router 3. Okay, let's check this interface. Ethernet 0/0. Okay, interface Ethernet 0/0/0 IP address 10.10.20.255.255.255.0. Okay, and let's come to our last interface, which is interface Ethernet 0/0/1 IP address 92.168.3.124. Fine. So now we have given our router IP addresses. So now let's verify connectivity from PC routers. So let's say maybe PC1 here into router 1. Let's try to check the connectivity from PC1 to router 1. So 10.10.10.2. Now you can see that the communication is possible. So now maybe let's check the communication between this router and this router. Let's check it. Quick. Okay, maybe say quick. Therefore ping 10.10.10.1. Now we can see that they can communicate, they can see each other. So now let's try to pin PC1 from PC6, okay, which is .6 here. Okay, let's come and say pin 192.168.3.6. Let's check request timeout, request timeout, request timeout. Okay, request time. Okay, that's very makes sense. Why? Because we just mentioned that the routers will discuss the packet with unknown destination. I mean, this router, its routing table doesn't know anything about this .3 network. So now let's check the routing table for this router. This view, a web display IP routing table. Routing table. Okay, now I've already mentioned the destination, the mask, the protocol, the course. So now let's check the components of this routing. Meaning this router doesn't know anything about 3 network. The same thing applies with here. So let's come display IP routing table. You can see this is our routing. So even this router 2 doesn't know anything about 3 network and 1 network. So now let's come to our configuration of static routes from router 1. So let's add those routes on those routers. So now let's begin with our router 1 here. Okay, let me arrange them from okay. So like I did mention there, the syntax is the word IP route static to 192.168.3.0 mask 24. The next hop, we did mention here that we are having an option where we can make the exit interface or the next hop IP address. So here the next hop IP address is 10.1, okay, 10.10.10.1. It's okay. Valid. Let me check. .10.1. The mistake here. Oh, I'm in the wrong route. Sorry, my mistake. IP route on router 1. IP route. Sorry, static 92.168.3.0 subnet mask The next hop IP address .1 is okay. So the word IP route again for us to add the two network IP route static 192.168.2.0, the same next hop IP address is going on, and 10.1.1. Okay, it's okay. So now let's check our routing table. Display IP routing table. Now you can see that this network has been added as our static routes. You can see that this network has been added as our static route. So now let's come to the router 2. So when we check our router 2 routing table, it doesn't know anything about .3 network and .1 network. So let's now add them into our routing table. So router 2 IP route static 192.168.3.0. Let me check the exit interface, which will be here 10.10.20.2 10.10.22. It's fine. Let's add the IP route for .1 network. IP route static 192.168.1.0 255.255.255.0. Let's check the exit interface or the next hop IP address, which is 10.10.2.2, which is the address of the router 1 in this interface here. 10.10.10.2. Okay, it's okay. So now let's check our routing table display IP routing table. Now you can see that where those this address has been added here. Let me check .1 network. .1 network, where is that? Okay. And this one here, it has been added. Okay, now let's jump to our router 3. This view display. Let's check its routing table first. Display IP route. Okay, now we can see that this network doesn't know anything about .1 network and .2 network, so we have to add them in our routing table. IP route static 192.168.1.0.24. Let's check the next hop address, which will be here 10.10.20.1.1 10.10.20.1. Fine. IP route static 6 network .0 24 and .20.1. Now it's fine. So now we have add our routing. So now let's try to check if the PC1 now can be able to PC3. So let's come here, check that and check it. Okay, amount. Now you can see that PC1 can be able to communicate with the PC6. Now let's check if our PC4 can able to ping with or communicate with the PC4 can communicate with the router 1. Where is our PC4? With router 1 online 10 10 10. Now they can communicate. Thank you very much, guys. Hope you like the video and have peace.